Hello, everyone. Welcome to the GeekNarrator podcast. I'm your host, Kaival Yapte, and I'm back with a brand new episode. Today, I have Luis with me, who has vast experience in the developer industry, right? And he has been like a developer. He has been into DevOps. He has been an SRE. He's been into leadership positions. And I came to know about Luis, and I worked closely with him while I was working at Zalando, and now currently he's working as a senior director of developer platform at Delivery Hero. Uh, Today we are going to talk about all things reliability of the system, and we are going to touch base on what is SRE. We are going to destroy some of the myths that people have, and also the assumptions that people make around DevOps, around SRE, and monitoring and observability, right? And so we are going to talk a lot about all this stuff. Uh, so welcome, Louis, to the episode. I'm really excited to have you. And let's start with a brief introduction.
Excellent. Hello, thank you for having me. I'm also excited to answer your questions. Um, as you mentioned, I am now leading the developer platform at Delivery Hero. It's a similarly sized, actually slightly bigger organization than my previous professional experience. Um, I did arrive with a lot of baggage around site reliability engineering, which is something that I'm very comfortable to discuss with you today.
Mhm.
But my new challenge is exactly starting to look at the velocity and the productivity side, assuming that reliability is something that I am more comfortable with.
Mhm. Interesting, great. So let's start very basic here, right? So when we say like SRE, so what does it mean, and what does it not mean?
Excellent question. Um, I think the industry as a whole did not do a great job at defining exactly this role and what it means. It's quite clear to me that the book, aka the Bible, when Google published back in 2016, did trigger a big movement, and companies
Mm.
started hearing SRE, and we should even be doing SRE, even without understanding exactly what that would be. Many
Yeah,
organizations try to replicate exactly the prescribed approach from the SRE book,
yeah,
even if they were not even 1/100th of the scale of Google. But it's fair. Um, Back to the discipline and the role itself. Unfortunately, that's the current state of affairs. There is no single correct definition for
yeah.
site reliability engineering,
Mhm.
but I think it's fair to agree on a couple of common characteristics and properties of what a good site reliability engineer in almost every other company could be.
Yeah.
One, which is still not always true in some of those overloaded roles, is
Mhm.
that site reliability engineering is first and foremost a software engineer. So they must have a solid software engineering background because it's a key enabler for all of the other interesting things that a site reliability engineer should be doing. And
Yeah.
what it should not be is, for example, running servers for another team or running the CI/CD pipeline. Those would not qualify, in my opinion, to what a site reliability engineering should be.
Mhm.
More a software engineer with enough breadth that understands the system level, but is also very conscious and looking at the final users of the software that is being written. And I
Yeah.
think this is exactly the right breadth for any site reliability engineering, being close enough to users. And if it happens to be the case that depending on different approaches of SR implementations, that you are running a central kit known as kitchen sink implementation with a
Mhm.
ratio of 5 to 1000, obviously you cannot be on every single service.
Yeah.
It's just not scalable. But in that case, having the empathy of the final users of those other services that other teams do, this is also
Yeah.
a key aspect of site reliability engineering, in my opinion.
Makes sense. And I think you briefly mentioned that, and this is one of the assumptions I guess people make. I also made, uh, once before I knew anything about site reliability engineering, right? So the assumption is that the SRE engineers are working at a very low level. They should know a lot of technical details, but they don't know, or they shouldn't know a lot about the features, about the product features, and who the customers are. But as you rightly mentioned, if an SRE engineer does not know uh, who is the customer of this product and what is the feature, and does not have the empathy, it's not going to be successful, right? Is it fair to say that?
I am very inclined to agree, but I realize that I should share a couple of disclaimers. First, I am not the holder of the truth of what is SRE. These are just my opinions, so I
Yeah,
should have said, in my opinion. In my opinion, this is how I view the role and the discipline.
yeah,
Uh, Now, coming back to your concrete question, I think that is also worth mentioning that uh, there are many teams with different products.
mm,
So if I am in the business of creating and providing to my customers a cloud platform such as AWS, it is very likely that an SRE in that company is going to be working with a lot of low level things like extremely large scale storage, which comes with all
yeah,
of the intrinsic optimizations of how to do that properly in a reliable, highly available, durable way.
yeah,
So if that it is your product, you inevitably work on low level things while being an SRE that I have no comments about. That's exactly the thing.
yeah,
But the vast majority of the business nowadays, the vast majority are not cloud providers. We actually know the handful of them that are around, or at least are worth
yeah,
the title. The vast majority are running all of these high level microservices that power our mobile apps in our mobile phones. Uh, Talking about my current employer, ordering food or other types of goods,
yeah,
we are not in the business of running a cloud infrastructure thing. That's actually how we use those cloud providers so
yeah,
that they do that job for us. So if you're not doing that low level thing, in reality, what is the great benefit of having someone that knows TCP/IP up and down your entire OSI layer and can troubleshoot network connectivity down to the data link layer? Very limited possibility because we don't even get that type of
yeah,
access in the cloud provider.
yeah,
So it is a bit of a myth in the sense that, generally speaking, because the vast majority of the organizations today are not in that level, it's not necessary. Both of them, in neither one of those cases, except in that your direct customer can be someone that uses your large scale storage system, it's your customer. So you should still have that empathy.
yeah,
Or if you are one of the creators of one of those microservices that power fashion e-commerce website or food delivery service, you should have the empathy towards the final consumer, which is just a transitive relationship.
mm,
uh,
mm,
in any of them. And at least it is my very strong opinion that in order to be successful at site reliability engineering, um, you should have these things very well developed: customer empathy and communication skills. These two will enable you to be very successful as a site reliability engineer on the majority of the implementations out there.
yeah, yeah. Makes sense. And I think we'll talk about this a bit later, but I think you covered it already uh, in a precise manner, that what it takes to become like a good SRE engineer, right? And we'll get to that a bit later in the episode. But I have some questions here, right? So there are multiple roles that companies have, and even like some companies just have like a software engineer role, and then they are responsible for doing everything. So they are the SREs, they are the DevOps, they are the DevSecOps, they are building features, they are looking at on-call noise and all that. So what is the difference between, let's say, a DevOps engineer and an SRE? Is there like an intersection?
That's so interesting. A very good friend of mine would say there is no such thing as a DevOps engineer, and I would be inclined to agree, because DevOps is truly about the discipline. It is not a role per se. DevOps,
Mm,
if anything, was the first trigger of the you build it, you run it sort of approach, which
Okay.
aimed at eliminating the silo between ops and dev.
Mm.
Um, Being a DevOps engineer basically means that, okay, we used to have two people with one leg on each side. Now we have a single engineer in the middle.
Yeah.
But I do understand how it has evolved into the DevOps engineer thing. It's just natural because if you are shifting the paradigm in how you do software engineering, building, testing, running, um, one way would be to also label someone as a DevOps engineer, and because they can do both sides and eventually see if you can just pay one salary instead of two, something like that. But this actually appeared in industry roughly at the same time that QA as a role was still very popular, still existed,
Mm.
which is also something that is no longer as prominent as it was before,
Yeah.
because the entire movement of you build it, you run it, which I think
Yeah.
it's common to all of this, has also grown more and more, and organizations realize that this reducing the cycles, the amount of changes, and having everyone actually owning it end to end from changing the thing until putting it in production and actually running it
Mm.
is the right thing to do. In that sense, would I go and say that is doing DevOps per se today? Probably, probably. But DevOps, I still see as that discipline that eliminated the silos, plain and simple, eliminated the silos. How exactly that is done, it's up to the implementation.
Yeah.
So, site reliability engineering is actually an implementation of DevOps with some
Mm.
specific ingredients that come along with it. One that is not part of any prescription of DevOps is service level objectives. That does not exist in the practice of DevOps.
Yeah.
But site reliability engineering, which follows exactly the same approach of there is no ops, there is no dev, brings in a couple of concrete ingredients on how to do that. And I think we're going to be talking about a lot of these things
Yeah.
because they come from the SRE space. So, in brief, DevOps I see more as a practice,
Mm.
as a very simple practice that eliminates the silos, and SRE is a concrete implementation of DevOps.
Yeah. Makes sense. And that I think that answers the question as well. Uh, with this, so site reliability engineering itself focuses on the reliability of the system, right? And let's say, so I'm working in a company, and I'm developing features, and as part of that, I also test the reliability of the service or the system I'm working on. And I also do all these kind of testing. I make sure that it is fault tolerant, it is scalable. Am I the SRE, or do I need like an SRE team to help me out? And when is it right to have like a separate SRE team versus giving the responsibility to a software engineer who is also working on a product feature?
Hmm. That is so interesting because it depends a lot on the current journey and size of any organization. That's exactly why just taking SRE's prescribed model and applying it is doomed to fail in the majority of companies because no one has their size or only a handful of them do.
Yeah.
Uh, and I've seen organizations, startups with 10 people trying to implement SRE by the book and
Yeah.
fail miserably because it's a startup. A startup
Mm.
needs, first and foremost, to create customer base, gain market share, needs to move fast, extremely fast. The reliability and its operational excellence should be second thought. And I say this contrary to all of my beliefs today, but I my journey is a bit far ahead than that, and I don't know if I would be very successful today in a startup that I understand that should prioritize those things.
Mm-hmm.
Um, so there is no right answer. I think that depends a lot on the different size and maturity, but there are actually like two or three evolving models of implementing site reliability engineering. I don't remember them all from the top of my head, so I will
Yeah.
refer that there is a talk from this fellow from Google, from SRECon, uh, Gustavo Franco, if I'm not mistaken,
Yeah.
and he showed exactly the different types of implementations of site reliability engineering organizations, from a team
Mm.
to team of teams, and then full blown organization,
Yeah.
and how it maps to the different uh, milestones in the journey in the growth of an organization. What problems can it still solve, but what it cannot solve,
Yeah.
and then also suggesting when to transition from one to the next one, which is always driven by exactly the growth of the business, the growth of the organization. That will always depend a lot on that. So, as I said, a very small startup of 10 people, now that will have four or five of them, including the founder, will know how to patch cables and SSH and do a deployment if they have to,
Yeah.
because that's what comes along with it. Because the risk of that idea not even taking off is so high that, talking about observability and all of these things, they would be great if you can have them out of the box and very
Yeah.
cheaply. Great, but this should not be top of mind. I think the product itself, making sure that it is being successful, will be more important for a period of time. And I'm not an
Mm.
expert to dictate when that period of time ends and the new one starts.
Yeah.
But at one point, it should be very clear that there will be a certain amount of services, there will be already paying customers on the service, and at that point, then actually the operational excellence starts hurting you.
Yeah.
And that might be a good opportunity to start with one dedicated SRE team, small one. Let's assume that you already have a 50 to 100 software engineers team. It could fit to have the known as kitchen sink, and I'm stealing Franco's terminology here, if I'm not mistaken, that the kitchen sink implementation is that first team which is very small, and the team charter is you do everything that you find it's necessary to raise the mindset, to start cultivating in everyone the practices that will make their lives better. You are not the one on call for those things. That is always
Yeah.
a mistake. You are
Yeah.
not the one running the servers or running a CI/CD, but you
Yeah.
are very tactically, not so much strategically, but you are very tactically identifying where are the biggest pains right now that our customers are experiencing, and you are partnering up with those folks with hopefully your deeper understanding of the entire stack and observability practice to help them get that under control
Mm.
through hopefully service level objectives, help that to elevate and restore some of the availability that the customers will appreciate, so that they don't leave your company and they replace you with another competitor. And then over time, as that grows, probably, I don't know, 500 people or even 1,000, obviously that single team will no longer cut it, because there will be four or five places simultaneously hurting the
Yeah.
customer pain. And then it should come naturally that that small team can no longer cut it.
Mm.
But then at that time, you probably also standardize how you do observability, how you do incident management. So a lot of things that fit very well into that space. Not, once again, not to be on call for anyone else's problems, but there will be the need for tooling, and there will be a need for governance and a solid structured process how to do these things very efficiently and train people in this
Mm.
regard. The observability, how to do best of breed observability, so that, facing an incident, you don't have people running around like headless chicken looking for a CPU or memory monitor that does not tell him what's wrong, but it might tell him what the eventual root cause.
Yeah.
As that matures, all of this seems to fit relatively well into a site reliability engineering larger organization.
Mm.
And then the sky's the limit, because I don't have personal experience of Google scaling how it went that far, but I
Yeah.
guess then it would be replicating this exact setup to other very large organizations where that level of investment would be appropriate.
Mm. Yeah, that makes sense. And I think you briefly covered some of the points that I was going to ask you next, which is like from the team side, from the company side. So let's say, so the idea is to not start having like an SRE team right from the beginning if you're a small startup, but focus on, the basic things first, like getting the customers, making money, making the basic user experience worth it. And then, but let's say I have reached that level and I want to have this SRE team to make my systems more reliable. What are some traits to look at when I want to build like a strong SRE culture?
Mhm. This is an excellent question. Once again, disclaimer: this is my opinion. Okay. um, a strong SRE culture would likely be something that I would detect by what is the on-call policy and approach,
Mm-hmm.
uh, which means are all of the teams on call, or is a central team doing the on call, or a small group of individuals centralized being on call. So I think that a stronger one would be utility run if people are on call for their own things.
Yeah.
But that alone would be a bit irresponsible, and it wouldn't
Mm.
say much about a strong SRE culture because it just means you distributed the pain.
Mm.
But now it would mean that metrics coming out of this. How high is the
Yeah.
false positive rate? How is the alerting approach? How is observability dealt with? Are they just monitoring, or are they actually being able to observe a distributed system?
Yeah.
If the answers to these things are that they are able to observe the entire distributed system, there is no single
Mm.
isolated view on my part. You know, there is a typically expression that easily gives this away, which is during an incident, a team says in a chat or in a room, everything is good on my side. And then someone else also abuses this term of my side. It's not on
Yeah.
my side. And this is exactly where the fallacy begins. There is no such thing as my side because it's still a
Yeah.
company with the same customer base, and this siloed approach of my side and your side is a strong signal that there is no SRE culture, or at least there is no strong SRE culture. In a strong
Yeah.
SRE culture, sure, everyone is focused on the services that they build and they operate, but when it comes to the customer pain exists,
Mm.
we're all on the same boat. It's the same customer. They are
Yeah.
not a customer of service A or service B when both of them are necessary for the service to buy shoes, for example.
Yeah.
And that would be a strong indicator of a strong SRE culture where, sure, I do understand that this is where begins my level of responsibility and this is where it ends,
Mm.
but it needs to be understood, felt even, that we all have the same ability to observe the entire distributed system. If I can support to restore this by even rolling back to a previous version because that about to trigger a failure in an upstream thing from another team that is harder
Yeah.
to patch, I should do it as well. And this is
Mm.
what some signals of what would be a strong SRE culture. The on-call approach, how easy it is to observe, how this shared responsibility is dealt with. And I
Yeah.
would not be very accurate about mentioning another interesting aspect, which is the blameless culture.
Yeah.
Blameless culture is the culmination of a couple of different things, which is first embracing failure. Failure will happen, it's permanently happening, and we're not going to pretend that it's not, and we are
Yeah.
not going to obsess about making failure impossible
Mm.
because the actual investment, the effort to try and still fail, it's so high that this is not the site reliability engineering way. The site reliability engineering way, it's rather embracing and accepting that it will happen. It's
Mm.
focusing on how well and how fast can we recover from that.
Yeah.
And this is an important aspect that if you are embracing failure, you are no longer just focusing on when bad things happen. You switch from the instinctive reaction of who's causing it to let me see if I can learn where the problem comes from and what can I
Mm.
do about it. And this is
Yeah.
exactly a key different change. If you ever go to a place and the first question they ask in an incident is who's causing it, run as fast as you can. If on the other hand, and this all builds up, right? All of the previous things
Yeah.
that I mentioned, they all build up
Yeah.
because obviously someone will be able to take this different approach of asking
Mm.
where is this coming from and what can I do. If you have better observability, if you also share some of that responsibility. So I guess I
Yeah.
would summarize with these traits.
Yeah. Yeah, I think that's a good summary, and I think there is a very thin layer of being blameless, and at least knowing the responsibility boundaries, right? Because uh, I mean, you can always say, okay, it's not my service, or let's say it's not this service, but the other service, and that makes it blameless. But if I keep saying, oh, it's this team's service and not our team's service, so that's become that becomes like a blameless blameful thing,
Full,
right?
yeah.
Like uh, so it's a thin layer, and I think it comes with practice to become blameless, because there's this, the human bias that we have. Oh, it's not my problem, it's your problem. But ultimately, like, getting it right is tricky, and there should be like a constant push to be, become blameless, and having these post-mortem sessions where someone is a moderator that, hey, let's not use, blameful terms like who was on call, who caused this bug, and who deployed it, and all that kind of thing. So it's a really thin layer, and
It is. It
but I
is.
think you
I actually
mentioned.
just remembered what you were describing. Thank you so much for using the words that you did, because you just triggered in me another very simple signal. It's very simple. If an organization has human error as
Yeah,
the reason why something failed, also run away. That is not very healthy,
yeah.
because that organization is not prepared yet to accept the
Mm.
fact that we can fix systems, but we cannot fix people. Medical doctors do that. We can fix systems. So if you point the problem as human error, it will always be blameful, because we need to
Yeah.
know which human so that we can fix it.
Mm.
We will fix
Yeah.
the human. So it is not much different to switch away. Of course, a bug is always introduced by a human, at least so far. Nowadays, GitHub has this Copilot thing that may start introducing some interesting bugs, but let's assume for the sake of simplicity that a
Yeah.
bug is introduced by a human. A human mistakenly deletes a load balancer or forgets to renew an SSL certificate.
Mm.
All of these cases, sure, I can point at the human, but
Mm.
how many different options of automation and guardrails can be implemented to prevent
Yeah.
humans from making that? And this is exactly the shift, right? If a human forgets to renew an SSL certificate, it's easy to
Mm.
say if they only have one to renew every single year, sure. Even then, when we are probably maintaining 2,000 at large scale, having someone whose job is to renew SSL certificates doesn't sound great as a
Yeah.
career.
Yeah.
So the fact that automation that does that efficiently without wasting
Mm.
someone's time
Yeah.
would be where I would not say uh, human error, but rather lack of automation and guardrails to protect
Mm. Yeah.
the system itself.
Yeah. Yeah. Having guardrails is so important. I remember one example. Uh, like someone in some other team, because I was just observing. So there's like a common incident channel, and I keep observing what is happening around the company, what is going bad, and how it is impacting us. So there was this discussion going on where, someone was doing some deletion of old data on a, MySQL server or something. So he was able to log in and, run this truncate table and drop table, all these kind of commands. It was meant to happen. It was just too early, because he was supposed to just, test it out, like how it is working and how it is impacting on a test table. But things go bad. People sometimes are distracted because of various reason, and he just truncated the production table, and that literally destroyed a lot of systems that were dependent on that legacy component. And it was, handled very nicely, to be honest, because they were not blaming that person. They did not even name him or what team is it, but they just kept saying, okay, we have like a really bad issue, and we want to get that data back and, get it done. So I think you briefly touched upon some terms that we often use. I also had this confusion, and I want you to clear that confusion for me. So we have monitoring, we say alerting, we have observability, right? What is the difference? When I say monitoring, is it not the same as observability? How is it different?
Well, yeah, in my opinion, no, they are not the same. And I think, unfortunately, once again, the industry might be to blame for that, because observability is something more recent, not recent by definition. It exists for quite a while. It's not even originally from our industry, but it was transported into the industry. But it is more recent, and there is actually only a handful of key players in the industry as vendors that are putting serious effort on trying to clarify what observability is, and many others that have monitoring tools are just riding the wave and then relabeling themselves as observability vendors because this is the hot new thing. This is very
Yeah.
similar to SRE and the role, and then how people just relabel themselves or someone else, and then uh, in the same exact same effect. By the way, in the role now they earn 30% more, but they do exactly the same, just with a new label. And a monitoring vendor now will charge 30% more by claiming they are an observability vendor. But this is not so useful. How I see the difference between observability and monitoring, and then I will also mention alerting. Um, Historically, monitoring is the ability to see a single component or a single thing that I'm running in production. And this was what we did back in the monolith time, when it was a single server running a single process, and monitoring was very adequate, because
Mm.
what we needed to monitor was like, is the process running,
Yeah.
basically. And because it's a single server, there is not more than else. Let's also look at its resources, which are finite, and we need to keep an eye on. We need a bigger boat. We need to
Yeah.
replace it with a bigger machine eventually, right?
Mm.
This was pre-cloud, pre a lot of the things that happen today. But a fundamental shift was from this monolith, which was easy, relatively easy to monitor.
Yeah.
So observability itself would still be applicable,
Mm.
but I don't want to digress too early. But it was monitored, and this was enough, because
Yeah.
you could measure the signals that were high level from that thing that your customers were affected by.
Yeah.
Well, in the last decade, there was a big change to microservices, to the cloud, a lot of dynamic and volatile infrastructure, and a lot of containers going up and down. At the end of the day, it does not change what the customers are getting. They
Mm.
are still getting some service over a mobile app, over a website. The only thing that changed was the internals of this. And this
Yeah.
is an interesting aspect. And this is exactly where observability comes from, in my opinion, which is we still need to be able to understand what's happening for our customers, for the users of our product, uh, acknowledging the fact that now this is no longer just a single box running a single process. There will likely be many hundreds, if not thousands, of processes running on many hundreds, if not thousands, of boxes, which we don't even know, because some of them will be hypervised in someone else's physical machine somewhere. And
Yeah.
those things are very dynamic, they come and go.
Mm.
Um, Also, because microservice does not bring just this physical nature of the distributed systems, it brings distributed teams, multiple different people with different contexts. And this is exactly what I still think is the biggest contributor to the change. With monitoring, a single individual or a handful of individuals understand the box, the service, the process, what it does. It was
Mm.
enough. In distributed systems, that is no longer guaranteed. A team, a group of individuals who will have a good, solid understanding of that part
Mm.
of the system, and they can monitor that part of the system. They
Yeah.
should. And there will be another one and another one, multiple replicas of that. But at the end of the day, your entire product as a whole only works, and you only understand it well enough
Mm.
if you get enough context of the entirety of the distributed system,
Yeah.
like back in the monolithic days. To achieve that, monitoring as we know it, which basically stopped, uh, in my opinion, in logs were the first iteration on how to monitor things, just emit logs, because a single box, all of the logs in the same directory, and it could grab them. This was fine.
Yeah.
This was enough.
Yeah.
Then it turned out that it was a little bit expensive when things started scaling a little bit more, and then logs were a bit expensive because they were also very verbose. And we figured that, oh, maybe we can pre-aggregate some of the signals that we're emitting as logs, and then having some averages and some percentiles of things. Then metrics were born, because essentially they are extremely cheap in comparison,
Yeah.
and this augmented our ability to monitor things.
Mm.
And we could also have baselines and aggregations of other interesting infrastructure signals such as CPU and memory usage, garbage collection, things like that. But this is basically what is still necessary today. We
Mm.
should still do that, and we should have the ability to monitor, to observe all of these different signals on every single actor that
Mm.
participates in the system. Uh, Now, why that is different, and the while we did this, while we did all of these things, and we went from logs to metrics, and we started growing and breaking apart the monolith.
Yeah.
The intermediate was probably the saddest part, which was we still apply those monolithic approaches in a distributed way with the
Mm.
teams and the systems. And then we felt like every single one of them had to follow the same practices by being alerted on each individual metric at times that is being captured. Because if you capture a metric, you need to do something with it. So
Yeah.
there is a temptation that all of the telemetry that you emit, doesn't matter if it
Mm.
is memory, if it is CPU, and many other things, okay, you probably want to create an alerting rule on it because you can always come up with no different above that threshold might be bad,
Yeah.
and you want the system to get your attention, right? You want to chime in and do something about it. And this is exactly where it
Yeah.
starts getting devious as well. The alerting part is that if you start alerting yourself on all this infinite number of possible root causes, you'll very quickly find yourself suffering from alert fatigue and hating your life, and this is not great.
Yeah.
This is a very important part, but I think we you might have other different interesting questions where I might go deeper into the details. So connecting now to observability. With observability, you first gain the ability to see the entire distributed system, and you need to be able to see that journey end to end. Even
Yeah.
if you have n teams with n multiplied by 100 processes running to fulfill that, you need to have that ability. And this is exactly where also introduces an interesting question. Well, if
Yeah.
observability is seeing this from the customer perspective, regardless of how it is distributed in the system, is there a new way to be alerted on?
Mm.
And what kind of technology could help us to achieve what I've been describing as observability?
Yeah.
I
Yeah.
hope that you have that question.
Yes. Yes. Yes, I do. I mean, I just want to summarize because you mentioned a few good points here. Uh, so I think first you mentioned, so you went into the history, the monolithic world, and then we split up into microservices, and then huge organizations have like thousands of microservices, and that's when it gets tricky, like what to monitor and what not to monitor. And then so I think the idea is to monitor from the customer's perspective, like what is not working, and not from the individual components perspective, because customers do not care how many microservices you have, right? If you have like a monolith or a microservice architecture, they don't care. They care if whatever they are doing on or with your product is working or not. So is the idea to be at a high level, being able to observe how things are working from the customer's perspective, and whereas monitoring is a bit low level, where each team can monitor certain indicators on their service level. And then alerting is basically on just to get notified if some of the observing metrics that you have are going above threshold or something bad is happening. Is that like a fair summary, or did I miss something?
Well, while doing so, I think inevitably you had to go through the same challenge that everyone does, which is how overloaded the terminology is, and how
Yeah.
monitoring is so prominent that it's so easy to just call everything monitoring. And
Yeah.
yeah, I'm not going to claim that I have an exact good definition for it. So your summary is very accurate. I would just add that monitoring is the ability to have signals, telemetry. It doesn't matter if it is a metric, if it is a log, if it's any type of telemetry, it could be a distributed
Yeah.
trace.
Yeah.
Uh, Capturing those things and being able to visualize them, that's monitoring. That is monitoring. because you
Yeah.
can do them individually as part of your troubleshooting process, as
Yeah.
part of your uh, response to an incident, the things that will help you show enough evidence that this is where the problem is.
Yeah.
Okay.
Yeah.
Why it is relevant, and I think your summary then concluded like that, is that this is not how any incident response story starts. This is not how you start an investigation. Never is.
Mm.
You start from a customer failure that is causing them
Yeah.
pain, and
Yeah.
hopefully you have good means to detect that, or you have your customer support line telling you about that, or they are ranting on Twitter that your website is not really working somewhere. So those are
Yeah.
also alerts. By the way, those are also alerts. Not the best
Mm.
ones that you would like to have, but they are alerts. They get your attention. But these
Yeah.
are still by far the best ones because they tell you exactly how much pain your customers are going through. How do
Yeah.
you fill the gap between what they just said
Mm.
to find out where does it come from?
Mm.
And this is exactly where I think that monitoring is not sufficient because
Yeah.
it is still very focused on I'm looking at the things that I know in advance,
Mm.
the things that I anticipated, the known knowns,
Yeah.
and does not leave an opportunity for how you go from something high level that a customer just complained about to
Mm.
where do we even start in a large scale distributed system? Which one of those Grafana dashboards would you start?
Yeah.
For
There are
example,
hundreds of them.
exactly.
Yeah.
Which metric out of 10 billion would you start by looking at?
Great. I think I have a good idea now. Let's take an example here, right? Let's build a small startup, like a hypothetical one, and then let's see what exactly we wanted to monitor and what we would like to skip, and at what stage I should create these alerts. So let's say I have a sandwich shop, right? It's like an online shop where people can come in, select their favorite sandwiches, and pay the price or cost, and just get their sandwiches delivered at their home. So this is a very simple use case. But let's say I have like a small startup. I have the like the front end team. I have the back end team, which is building these microservices. So there's this products, or the sandwiches are the products here. So products team, and then there is like a orders team which is dealing with the orders, and then there is the delivery partner integrator or something which integrates with the delivery partner, right? And then of course there is a data infra team which manages all the storage engines, and you have, so I have like a 50 member team. I'm just creating a startup. uh, Now let's say something goes wrong. So people say so on Twitter that, hey, this is my favorite sandwich shop, but I'm not able to order. I'm not able to order these sandwiches. And some people are complaining about the delivery times, right? And some people might be complaining about, let's say, their payments failing or orders not going through. Some people might be saying, oh, it's too slow. So there are so many problems and so many things can go wrong. And I am, let's say, the head of SRE. I want to implement this culture. So where do I start? Where How do I, as a head of SRE, how do I get this observability? And as individual teams, what things should I monitor?
Mm, very, very good. Excellent. Starting with the simplest one, because that is the one that does not need so much effort, which is what should each individual team monitor?
Hmm.
And I translate that just to how much telemetry and what type of telemetry they should emit in order to
Yeah.
help themselves or anyone else to
Hmm.
understand during a troubleshooting exercise, uh, validate or invalidate certain hypotheses. This is where it's coming
Yeah.
from, and this is what's happening right now. But this
Yeah.
is not enough, as I said before. This is just not enough. So, in terms of
Yeah.
what monitoring teams, different teams should have as much as they can afford.
Hmm.
I can elaborate on how much they can afford, but they should capture as much as well. That actually means also the containers, properties, and health, the CPU, the memory, everything that can help understand either in real time during firefighting or later why a
Yeah.
performance regression happened. So monitoring fits very well here, which is capture as much as you can afford. Now, what you could do as a head of SRE for that particular business would be you cannot do this team by team because it's very
Hmm.
unlikely that a single team of those actually has full ownership vertically of one critical business operation. That
Yeah.
is typically not how teams would be structured. They would like there is a customer facing application team probably with some micro front ends of sorts, and then
Yeah.
others contributing, or maybe there is a monolith CFA with many backend services from the different teams contributing to it.
Yeah.
At least I am not very familiar with many organizations that did it vertically without any exception.
Yeah.
And this is already suggests that if no single team owns what you could identify as a vertical critical business operation, that would be
Mm.
your first exercise. Your
Mm.
first exercise would be some more higher management, even executive level sponsors to help you
Yeah.
identify what is the set of business operations that are critical for the business.
Mm.
And this is why these folks are great sparring partners for this, because they
Yeah.
definitely do not care about
Mm.
microservices and databases and Redis caches and things like that.
Yeah.
These are awesome for engineering, but they do not know that. So this particular exercise is better done exactly with executives, product managers, people very senior that has the same holistic understanding of I run the business and selling sandwiches.
Yeah.
Obviously, they will start by very high level. I want to sell sandwiches. Well, that is not enough. We need to go a little bit deeper.
Yeah.
And usually this results in where the typical synchronous touch points of the customer journey happen.
Mm.
They land on the app website or something for the first time coming from SEO, or they land on the homepage because they type the URL they saw in an ad. It doesn't matter, but they land here. And then
Yeah.
they will have different funnels how they eventually get to the point that they place the order.
Mm.
This is actually a handful of steps. This is like half a dozen to a dozen steps. It's not that
Yeah.
much. Sure,
Yeah.
the permutations of the steps that then can take, they will be tremendous. And this is
Yeah.
exactly why it cannot be so holistic, because then you find yourself with too many variations of what to observe. And that is good for analytics, but is not helpful for real-time alerting and symptom-based approach to
Yeah.
observability. So what you want is exactly the discrete touch points so that you don't have to deal with the permutations. You
Mm.
consider one touch point as critical, another touch point as critical, and you actually don't care so much how they go from here to there, because that needs to be detected differently. One could argue that proper business monitoring would predict and also look at these things. But if you just stay at this level, you're going to cover, honestly, almost
Mm.
everything that is relevant at the right
Yeah.
level, which would be viewing the catalog, viewing a product detail, viewing a sandwich, adding the sandwich to the cart, changing the quantity, placing the order, selecting the payment method, paying for it, or placing the order, assuming all of this happens in sequence. You can identify this small set of business operations that are considered critical, and this is the
Yeah.
best starting point that you could have. Because by
Yeah.
having that set, now the question is much, much easier, which is where do I capture the best signal to noise ratio that
Mm.
represents the success rate of that operation?
Yeah.
And you will find them likely, and that should be the case, as close to the customer as possible.
Mm.
So an ideal way would be in the browser, right? But the
Yeah.
closer you get to the customer, the more noise you're going to get, because
Yeah.
they may be in the underground train, they may just taking off from a flight, their internet just gone out, and all of that would eventually count as errors of your platform, but it's not true.
Mm.
So the closer you get, at one point you start degrading the signal and you get more noise. So you can be closer. For example, in the actual service that receives the backend service that receives that thing, it also has a lot more context than, for example, an intermediate infrastructure such as a load balancer. Load balancer
Yeah.
will typically just know about HTTP, and if you go to the service knows way more than HTTP. For example, it knows that this was the payment method and you are visiting me from this country. All interesting properties that can help you fork even some alerting rules. Or
Mm.
when you troubleshoot, even if you just have one single rule, you can immediately, modern observability tools at least will do that. They will tell you that, oh, we're seeing a pattern here that with this payment method coming from that country, all of the orders are failing. So overall, we are still at 90% availability, but with this payment method from that country, all of them are failing because it's a local payment provider issue, for
Yeah.
example.
Yeah.
So this is basically what I would recommend you to do. Partner up with senior management, identify the critical touch points, the discrete ones, not like a continuous journey that takes half an
Yeah.
hour or so, the discrete touch points, and then instrument if it's missing in the place that you would identify as the best signal to noise ratio. And I already gave you some hints that ideally as close as possible to the customer. But if you get extremely close to the customer, like in their own device, this will
Yeah.
also generate a lot of noise.
Nice. Yeah.
So you may try that, but then a good starting point will always be in your first immediate point where you control with enough domain context. That would be a sweet spot, but then you can always play by moving closer or moving deeper.
Yeah. Yeah. That makes sense. And uh, with this, I want to ask you like how. So I have a couple of follow-up questions here, but I want to jump on. How can distributed tracing help here? And uh, so first of all, what is distributed tracing? And I've seen some companies uh, implemented distributed tracing and they love it, and they continue doing that. But some companies tried to implement that, and then it did not work. It was just too costly and it was not useful, and then they reverted. So is it a hard problem to solve this distributed tracing, and how it can help my sandwich shop?
Yeah, I agree, and I have done that exactly um, before. And if I would have to point at something that makes any attempt of implementing distributed tracing to
Mm,
fail, uh, is exactly because it is indeed hard. The entry to it is indeed hard. Let's try to establish why it is exactly hard. Uh, by the name and the definition, this thing will do distributed tracing, which means trace an entire journey of an operation from the
yeah.
very first place that you receive it and you start tracing it, all
Mm,
the way that it cascades transitively through infinite number of, well, hopefully finite, but many nested uh, remote procedure calls. This is the
yeah.
most typical case, and this is where it really shines. But until you get this value, until you get to see an end-to-end uh, uh, approach, you still need to invest a lot upfront. And I think this is the main
Yeah.
reason. You need to invest a lot upfront. So in the open tracing websites, there was a very strong recommendation that I admit that I did not originally understand why is this the best way, but today I do understand why it was the best way. And the prescribed approach was the crawl, walk, run, where you should not start in breath, like
Okay.
try to instrument everything in the whole company.
Yeah.
That would be doomed to fail because the effort is going to be way out of proportion of
Mm,
time and the return of the investment. It will take a
yeah.
lot of time because you only get to see the value for this when you get a full end-to-end trace with a lot of contributors and then piggybacking some of the things that I want to mention. So the crawl walk run really suggests start with the highest value operation and just instrument the things in that path,
Yeah.
which will likely be a much smaller group of services and teams to engage with. They will put that
Mm,
effort, but you have that high level operation fully instrumented, then all of the value of distributed tracing starts coming in. One of them would
yeah.
be exactly the alerting rule.
Mm,
With distributed tracing on a threshold here, and let's not go into much more evolved things of finding which service is actually failing to page that one. Let's assume that it's a small company of 50 people in the Sandiwch shop. Sure, you will have that on call team. When this thing detects that we are failing to place the order, this thing will alert. And just by looking at the observability tool, this will immediately show you right now in any sample trace, this is the service that is failing right now.
yeah. Yeah.
This is already so much better than any of the previous attempts because the previous attempts, keep this in mind, would be every single team on every single service would put alerts,
Mm,
which means all of these had alerts, including the one with the actual problem, but all of the ones before also did because
mm,
it failed for all of them as well.
yeah.
And this is exactly what makes it not sustainable because it will lead more to the blameful approach of who's causing this and why I'm being paid for this. Can
Yeah.
you make your reliability better because it's hurting me? Well, if it wasn't hurting them, this would all be good.
Yeah.
And this is where distributed tracing does help teams to live better, healthy on-call lives. And beyond that, actually understanding what is driving the lack of performance of placing an order. What is the
Mm.
thing that is taking 85% of the time? If everyone is looking individual at their service, well, you only benchmark against yourself. You don't have anything else against to calibrate with. But if you
Yeah.
see it from the perspective of we are looking at the place order operation and
Mm.
85% of the time is spent in service X, well, it's a great suggestion that if there is a
Yeah.
goal to optimize the latency of the placement of an order,
Uh,
we know where to start,
yeah.
where 85% of the time goes. And
Yeah.
this is exactly where distributed tracing helps. But I think it's also the reason why it's very easy to fail rolling it out. Uh, I am of the opinion that the crawl, walk, run, as it was prescribed, and starting is actually the most valuable operation first.
Yeah.
It is the ideal approach because by demonstrating that value, teams that were involved in it become cheerleaders and they will understand the value that they are getting, how their lives are is becoming better. They will also share with the other teams how they did it, how much effort went into it, and they got in return. And then
Yeah.
this should happen consecutively over time. Any attempt of trying to roll out distributed tracing in breadth in one shot,
Yeah.
it's likely bound to fail.
Mm. That makes sense. So I think in my sandwich shop, if I pick up like a couple of like high impacting workflows, let's say placing an order, and then apply distributed tracing in that. So I think that will be like very valuable as compared to, just apply distributed tracing to everything, like making an order, searching for a product, and looking at or tracking the status of your order and all that things. So I think that makes sense. um, and coming back to my second question, which was about the SLOs, right? So uh, I want to have some service level objectives.
Mhm.
So how much time does the customer need to wait before they can actually get like you know, a successful response that, oh, your order is successful and this is the time you will get your sandwich? How do I get these numbers, right? So
Huh.
I cannot just say, okay, 5 seconds is my SLO, but there needs to be some data, some testing done. So
Yeah,
how is usually these SLOs designed, and on top of which companies build those SLAs with other partners, right?
yeah.
So how to approach finding SLOs?
So there are many different ways, and I'm assuming that your question is more of pragmatic ways that you
Yeah,
can address this without overcomplicating it.
yeah.
And the truth is, this is in two different approaches, which is the bottom up. And the bottom up would be you are very well aware of what you depend on,
Mm,
and they already gave you something explicit. This is what they can promise you. This is easy. For example,
yeah,
you are running one service directly on AWS, a single EC2 instance. The single EC2 instance, I think, is 99.5 or something, something. But
yeah.
they do report their SLA to you as an external provider. And you know that you will likely be a mistake to promise more than that.
Mm,
So you do bottom up, which means if you have that much as a maximum, you want to reserve some failure budget for yourself, you
yeah,
deduct a bit, like a zero point 0.5 for yourself, something
yeah.
like that. Okay.
Mm,
And this is the bottom up approach, not the one that I think would fit well in your sandwich shop. Your sandwich shop, I don't think you are the only one sending sandwiches using the same business model. I would definitely just very quickly scout my competitors.
mm, okay.
Scout your competitors, do some very basic statistics, average them out, and see how quick they usually are. If you are much slower than them, even if
Mm,
your product is much better, these things are going to be competing and you are losing opportunity. So I
yeah,
would just go with be better than the best of out of them, or at least try not to be worse than the average of them, so that
yeah,
you will find yourself somewhere in the middle. So this is always very effective. And keep in mind that what are you comparing against? It's no longer service A or B or C because that is not
yeah,
comparable. That's exactly
yeah.
why SLOs on each individual service are typically useless. They are not very useful, unfortunately, especially at that maturity stage of your sandwich shop. You barely just introduce distributed tracing on one critical operation, so stick
Mm.
to that one. You want an SLO for that particular critical business operation where the signal is being captured close to your customer. That's the SLO that you're going to define for the operation, not for any individual service that will eventually be renamed and replaced with any other one. So this SLO will stay for as long as your business doesn't change.
Yeah.
And that gives you something comparable with your competitors. You're going to see if your critical operation force placing the order, you're going to see in the other sandwich shops how long does it usually take to place an order. You may actually grow a couple of kilos by eating so many sandwiches from your trials, but
Yeah. Yeah. I think it makes sense. I have one question on one point that you made, that each individual teams may not need an SLO. Uh, but then let's say I have, the cart service, which is making a call to, the order service to place an order actually. And if I don't have an SLO on order service, does it impact in a way to the card service, that how much timeout should I have, and how do I figure that out if they don't have SLOs?
this is actually extremely, extremely hard. So since I assume that we're talking about a pragmatic approach to it, I did not suggest any of that. And I still would not. Okay. It is extremely complex to do that correctly. Honestly, very, very hard. For one, I don't think it's even possible to have static timeouts
Yeah.
because as you sit in a portion of the distributed system, you may be called by different paths that you not anticipate,
Hmm.
which means as that flows past you transitively to the next one, you also don't know how deep it will go.
Yeah.
You are
Okay.
just an intermediate. So believing that at least for a timeout, a time-based expectation, that you can just go with 100 milliseconds and timeout because this is my SLO,
Hmm.
it is a recipe for disaster. Where what I've seen in practice in the field is, yes, everyone tried, and then eventually you find out that in a nested call, the previous one had a more aggressive timeout than the next one, for example, which
Hmm.
should not be the case because this, if this was working properly, everyone will
Yeah.
know how much. So the actual solution for this problem, or a solution for this problem, and here I think Google did nail that one, which is on the remote procedure calls, they pass on to the next hop how much budget in terms of time they can still afford to spend.
Ah. Okay.
So along with your remote procedure call, because they use, I believe, gRPC, protobuf, things like that, as
Yeah.
part of your remote procedure call, you are informing your next hop, and you still have this budget to spend if you can afford it. If not, don't even try yourself to do the next remote procedure call because you don't even have time
Hmm.
for your own processing. Just back off and fail earlier. That I'm canceling this request because I won't be able to fulfill it.
Okay. Makes sense.
And this is
So
dynamic timeout approach where you get a budget, you set a timeout doing your remote procedure call up to that one. If you don't receive it within that time, you time out and you come back.
yeah. 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 That is a very interesting approach. So I tell you how much time I can wait on you, and then you decide if you want to perform the next operations or just fail fast and give the response to me.
Exactly.
So that is a very interesting approach.
And
And
by the way, in
and
distributed
then
tracing, this is also possible because distributed tracing has a mechanism called baggage that is a
mm,
way to carry metadata, key value pairs,
yeah.
in your remote procedure call. It goes along with it with the span context. So it's part of the span
Yeah. Yeah.
context,
Yeah.
which means the receiving end needs to extract the span context in order to continue the trace, but it can also extract the baggage. And if this is very
Yeah.
well defined, you can also extract that and do your math, do your deductions. Oh, it's negative. Negative, give up. No, it's still a positive number. Inject it in your own remote procedure call span context and pass to the next one after deducting your part of the cost, which you will get from typical baseline, how much time you need to do your part of the processing.
Yeah. That is very interesting. And I guess then, since we are talking about timeouts, then let's say something fails, I want to retry the operation, assuming it is idempotent, and so I can also retry with these dynamic timeouts again, right? So the for example, the retry number two might have like higher timeout because the first operation was quicker this time, right? So that also helps in retrying dynamically. So that is very interesting.
Yeah.
uh, cool. So since we are talking about SLOs, right? So SLOs usually are these P99 and P99.99 and whatnot, and they are called like three nines, five nines, seven nines. And like since like people talk about different types of SLOs on durability, availability, uh, so how do I know that how many nines I want to provide as an SLO? Why can't I just say okay 11 nines? And what is the cost on having that extra nine of, let's say, availability or durability on my service?
Excellent question as well. And I was already finding you were going too far with the seven nines, but you went to 11, which is great. Um, I am afraid that figuring out the costs for an additional nine is much harder
Mm,
to answer
yeah.
in comparison to understanding how much did it cost the previous nine if I actually walk
Mm,
backwards. What do I mean with that? We do know that the cost of additional availability with an additional nine is exponential, but we just don't know how steep. So the effort to actually get the next nine just for the sake of learning how much it would cost, I don't think you can easily predict it because you need to factor in including the engineering effort to achieve
yeah.
that extra nine. It's not just cloud compute, for example. That would be
Yeah.
easy, right? If you throw another five servers to it and then you can estimate it in advance and hoping that you will get another nine. And maybe you will.
Mm,
Maybe you will. And that should be easy. And if you had that opportunity to try it out for a couple of minutes, see if you got the additional nine, compare it, that should be okay. But this is going to be hardly the case because you need to factor in the engineering efforts, how
yeah.
fast you're going to make your on-call incident response. Even on even on five nines is already a ridiculous budget that you get. So
Yeah.
anything further from that, I don't think any human could reasonably guarantee such a high level of
Yeah.
reliability. Anyway, you could still try to mitigate it with many other different means in the way that the system is built to deal with resilience. But I think there is something more practical that you can do, which is if you want to optimize costs and you have a couple of opportunities, let's consider, for example, switching on demand instances to spot instances. And you want to know how much is it worth. So you know how much it's going to be worth if you convert from one to the other. You already know what you
Yeah.
are doing the reverse lookup. You are now saying that if I do that change, saving that amount of money, how many nines did it cost me? So
Yeah.
you can do this in reverse. And you can do this for a short period of time. Just try to
Hmm.
understand it, which would
Yeah.
be, for example, you are measuring for a long period of time already your baseline. This is my availability in on demand. Okay, this is how available it is, and it seems that it has a solid baseline on, I don't know, it is three nines available. Okay,
Yeah.
and then you switch from on demand to spot, which will likely then over a longer period of time will have some replacements of spot. To nowadays you can even fall back to on demand automatically, and you should leverage all of that automation because it comes for free. Just it comes out of the
Yeah.
box. So why shouldn't you? And then over a period of time, you need to observe exactly that the change that you did were there spot replacements. Yes, there were.
Mm,
How
mm,
many? These many during this time. And then you can go and compare a similar cycle to a previous full cycle and how much availability did I lose by doing that change.
mm,
And then it's a different type of question, whether also a different type of answer, but could be equally helpful, which is I save this much money by losing this much availability. And this will
mm,
always be very specific, very unique to every component, but this is an exercise worth doing, especially because if you are doing a, I don't know, sharded Redis versus single Redis, whatever, you are
yeah.
considering something like that for additional availability, and you have the availability up there on the place porter operation. The deeper you go into the system, the less likely it is this is going to have a big effect up there. So this will
Mm,
hardly make any dent on this high level SLO. If you have SLOs per services or something like that, then you will see immediately the consequences. But
Yeah.
Once again, this might be pointless because if the previous caller from you is already retrying and their success rate on the second call is five nines, your optimization was not really necessary.
Yeah. Yeah. That makes sense. I think I think this is a practical approach. But the I think the only limitation is that you know you need that ability to test things, right? So, for example, you went from, let's say, dedicated servers to spot servers, and then you have this, less availability. For example, that you reduce your availability by 0.00 something 9. Uh, but then there is always a risk, right, that you are being less available. So you don't know at this point when you're moving from dedicated to spot how many nines you're going to, cut off from your availability, and how is that going to impact the customer. So I think we need to be really careful while doing that, and really, monitor things or observe
100%. By the way, this
things.
all built up, right? You define the
Yeah.
critical business operation placing an order, right?
Oh yeah.
Let's assume that you benchmark yourself against your competitors and you found out that three nines was the success rate from all of them. You went with the
Mm.
same, okay? You
Yeah.
went with three nines. And you measured over a period of time and you know that you are consistently delivering four nines, okay?
Mm. Yeah.
But your SLO is actually three nines, but you are delivering four nines, okay? This in
Mm.
practice means that you have an error budget, which is quite generous because you're already
Yeah.
fulfilling, you're only burning 0.001% of your budget, and you can afford to
Yeah.
burn another 0.09. Okay,
Mm.
that's
Yeah.
exactly where the monitoring comes in. You have that baseline very solid, and you know this is how it behaves. Then you introduce the change, and you actively monitor that thing. If you start seeing the error budget burning down, and this
Mm.
is not like time based, okay, because there's also a mistake of confusing uptime with availability. And we're not talking about operation oriented observability. You actually do
Yeah.
not care about the time, the absolute time. You want to make sure that when an operation happens, so a user makes a
Mm.
request, you can fulfill that one. If there's only one request coming every 10 minutes, well, you could have been down 9 minutes of those 10 minutes, completely
Yeah.
down, that no one
Yeah.
would
Yeah.
notice. Why should you pay with availability when it was not necessary? And this is a confusion
Yeah.
because it comes from the infrastructure approach, where you're in the business of providing compute.
Yeah.
Well, the machine needs to be up because you don't know anytime someone's going to need it. So it just needs to
Yeah.
be
Yeah.
up. But for operations, it's not the case, right? You measure availability by other mechanisms, which means that it would take a while for you to
Mm.
see that happening without you noticing. It's not like
Mm.
switching to spot will immediately be catastrophic that your entire fleet would disappear. That
Yeah.
could happen in some extremes, but you are actually looking for the most predictable thing, which is recycling of spot instances, like losing a replica
Mm.
here and there. And by looking exactly at your error budget and the trend, because you already see that the shape of that curve of eating the error budget was a rather flat line, when you switch
Yeah.
to that, you likely see that shape changing slightly, and you should definitely look at it for the same period, because as soon as you see it accelerating far too much from what you predicted,
Mm.
pull the plug, go back to on demand. You did the
Yeah.
experiment and you run out of that budget sooner,
Yeah.
which means you do the experiment within the boundaries of your budget.
Mm.
And then if you see the trajectory, you can already do some basic math estimates that, well, it seems that at the end of the period, we would eat up two nines from our availability. Is that acceptable or not? And then you are
Yeah.
comparing how much it costs. This is how much
Yeah.
money you save for those two nines. So we do the reverse exercise, but you can finally answer these two nines cost us this much.
That makes sense, and that seems very practical approach. So yeah, and I think with all the insights that you have given, my sandwich shop will be really successful. And I'll be like one of the best head of SREs. So thanks for sharing all the insights. Coming to the last section of our episode, right? So moving slightly away from the technology side and technical aspects, I get this question from some people that, how do I transition from a developer role to an SRE role? And, what are the tools or what are the tech stack that are pretty famous among SREs? So if I wanted to apply for a job and I want to be relevant in the job market and really be competitive, what tools or tech stack should I know?
Hmm. So I think today, and again, I'm going to, as a disclaimer, say that this is rooted on my perception and definition of what SSRE role should be. So I'm not passing
Yeah.
any judgment on everyone out there having an SRE role. Okay, this is for my uh, perceived ideal SRE role. I
Hmm.
think the so there are the soft skills that I mentioned earlier that are very important to develop: communication, customer empathy. If those are not things that you feel connected, that you enjoy talking with others, and instead of mandating things onto them, actually negotiating with them to trying to demonstrate the benefit for themselves about something.
Hmm.
If it's not something that you can easily do, either develop it or maybe SRE, the way that I would see is not the best fit. Customer empathy is a requirement. At the end of the day, you'll be the glue between a product engineering team and the
Yeah.
business and the product organization and
Hmm.
operational excellence. And this is the value that you bring into the table, is point out where there are opportunities and then partner up, suggesting things that can be done within a reasonable time frame and investment. How can it be progressively done better? Sometimes you're
Yeah.
just lucky that not only goes from better, it goes to excellent, and those are your big wins, and you should celebrate that as well. But customer empathy and great communication skills should be something more important in SRE than software development. I think everyone should have them, but not to digress too much, I think to switch to SRE, given the engagement that is expected from the role, even more so. So the technical aspects and tools, I think nowadays the most important thing is really observability. Being very familiar with where logs are good enough, where metrics are good enough, and where distributed tracing, what types of problems does it solve, and how to approach that.
Yeah.
This is key. This is the most important aspect, because all of your negotiations, all of your demonstration of impact is going to come
Yeah.
from your ability to observe and demonstrate.
Mm.
So without that, your job is going to be 10 times harder,
Yeah.
and you will find a lot of resistance. And you should avoid at all costs pointing at any team, you are terrible doing this, look at that. That would be a poor approach. So observability, so first, understanding the observability stack, what is good enough, more importantly, when something is not good enough, when logs are doesn't don't help, when metrics don't suffice, and understanding how these three things can complement each other and give you a very holistic view, regardless of the underlying roles, as infrastructure engineers that run Kubernetes, or someone that is actually running a load balancer, or someone that is running an actually microservice. All of these people at the end are part of the game, and
Yeah.
observability requirements are distinct for each one of them. And all of these can be tied together. And this is something that an SRE role can clarify, can help.
Yeah. Yeah.
Um, so observability tools would be my biggest recommendation to become really good at understanding how to instrument and emit signal from the service that you are helping develop.
Yeah.
Would be the connecting thing between these two. As an example, because a lot of people end up doing this. They have Kubernetes. Prometheus is a very popular tool in the monitoring space. So they put together an excellent combo, by the way. Kubernetes and Prometheus, great open source tools. Everyone can uh, set that up easily. And they believe this will give them observability, and that is not true.
Mm.
That will emit interesting opinionated metrics, most of them coming from the underlying infrastructure. Sure, you can also still instrument your service and your applications and emit some metrics, but most of them will also be emitted out of the box with those SDKs that do that job. But
Yeah.
that tool is never enough. You can achieve monitoring with that toolkit, but you will not really achieve observability. That's why connecting again to that definition of the SRE, of seeing this holistically with the customer empathy, there is only one way out. You will be the glue putting all of these things together, seeing the holistic distributed system. And you can only achieve that with specific distributed tracing. It can be augmented and supported with dedicated metrics, when you already understood there is a problem at the high level, and where is it coming from? When you get to that
Yeah.
step, then you need all of those things. You need the logs, you need the metrics, you need everything from the infrastructure, from the service, to help you understand what is causing it right now. But
Yeah.
this will not fill in the gap between customers are not able to place orders. Where is it coming from? Where do I even start looking? You won't
Yeah.
pull one of those 10 billion metrics out and here it is.
Awesome. Awesome. I think that clarifies a lot of things. And I was sure that while I talk to you about all these SRE, it's going to be a very interesting discussion, and it was very interesting. It was very insightful. So thank you so much for sharing all these details, like really practical details from your experience and clarifying all those doubts. And I'm pretty sure this episode is going to help a lot of people understand SREs and all the things around, and break down all the assumptions and myths that we have. And also, if someone wants to transition into SRE now after watching this episode, I'm pretty sure they are going to have like a clear picture. So thanks a lot. And I really look forward to collaborate with you more. And I also hope that you also enjoyed the discussion.
I loved it. Thank you so much for the very insightful questions and give me the enough time, which I also understand it was a bit more than we had originally planned. But I guess that's what happens when you're very passionate about a certain topic. So thank you
Yeah.
so much for having me. It was really a pleasure, and I hope that others can learn something from this.
I'm pretty sure. So, to the viewers, please subscribe to the channel and hit the like button so both of us can know that you really like this episode. So, thanks for watching.